So I want to show that for any constant, a real constant k, the integral of t square e to the power negative kt is equals to negative e to the power negative kt, a over kt square plus b over k square t, so on and so forth, when these are arbitrary constant and ABC are constant union. So for this, what we need to do is basically you know the integration. This is a question testing you on integration techniques, right? So you either use something that can be by substitution, by parts, or by formula. So looking at this, you can tell that one way to go is by doing integration by substitution. Okay, so we will choose one of the terms to be differentiated and one of the terms to be integrated. So I'm going to choose this to be differentiated. I'm going to choose this to integrate. So I'm not going to go into the nitty-gritty details of integration by parts. Okay, I hope you are able to do. Okay, so integrating e to the power of negative kt, what I'll get is negative 1 over k e to the power negative kt. Okay, then I'll write down t square, right, minus the integral. Okay, then I differentiate my t square. Okay, so I'm choosing this to be differentiated. That will give me 2t. Okay, and I write down multiplied by the negative 1 over k e to the power negative kt bracket t square dt. So remember that in our formula, when we integrate u dv dx, so called dx, this is the integration by parts one. Though this part will be our v, is we integrate. Then after this one will be my u minus the integral of du dx, and again v dx. Alright, so that is the essence of the integration by parts, alright, which I will not go through in detail. So I'm going to go back to this formula here. Okay, and how we can simplify this further. Okay, so next integral, this is equals to simplify my answer further, negative 1 over k t square e to the power negative kt minus, alright, I can see that minus and minus, I'll simplify, do side by side. I'll simplify basically this whole equation. I'm going to write it as tidy as possible. So I'm going to take 2 and k out because these are two just constants that's not involved in the equation. I'm going to combine minus and minus to give me a plus. So it gives me a plus 2 over k is going to come out. Integral of t over, this is t cube basically. T cube, right? There's no t square. I made a mistake. This is no t square. So please ignore this. So this is t and e to the power minus kt dt. Alright, and one more time I'm going to apply integration by parts again. Okay, and this is just integral 2 over k, integrating left side, minus 1 over k e to the power kt multiplied by t. Okay, minus the integral of, again, minus 1 over k e to the power minus kt, and differentiating this just gives me 1 dt. Okay, with that, simplify my answer further. If I integrate this is just very easy. This is just integrate k one more time is k square. So work it out. We have minus 1 over k t square e to the power minus kt minus 2 over k square t e to the power of, sorry, this is minus kt, I left it out, minus kt. Then integrating this whole portion and combining the answers, they give us negative 2 over k cube and e to the power minus kt. And of course I have an arbitrary constant. I'm going to put it as d. Alright, and with that, factorizing out my e to the power negative kt, I realize that I can factorize all of them out. So this is just going to give me 1 over k t square plus 2 over k square t plus 2 over k cube plus t. Okay, and we are done with part 1.